I'm Nick Houtman. I'm the editor of Terra magazine here at Oregon State University. On November 17th, Warren Washington received the nation's highest scientific honor, the National Medal of Science, in a ceremony at the White House. A couple of weeks before that, he came to Corvallis, and I had the chance to speak with him about his scientific accomplishments, his love of science, and the challenges that he sees facing today's youth. Dr. Washington, thank you for being with us this morning. My first question for you is about your accomplishment as a climate scientist, climate modeler. Now, I had a chance to look at the information that was in the National Academy of Engineering citation for you some time back, and it said, and I quote, "You pioneered the development of coupled climate models, their use on parallel supercomputing architectures, and their interpretation." Now, for those of us who are not climate modelers and don't know what the heck that means, maybe you could translate that a little bit for us and tell us what that did, what you did with that.
Well, I think I'd like to start a little bit earlier than on that achievement. I was one of the pioneers in building computer models of the atmosphere that later became models of the Earth system. I started really back in 1964 when a small group of individuals at the National Center for Atmospheric Research in Boulder, Colorado, put together a model of the Earth's atmosphere. And that was one of the 4 groups in the world that was working on such things. And then as time went on, the atmospheric model was coupled to ocean models and land models and vegetation models. And so we were able to make essentially climate models or Earth system models. Now, in the late 1980s, the computer architecture for supercomputers changed. It was very large, what we call vector computers, that were able to do calculations at very high speeds. And what happened in the computer industry, it switched over from these vector computers to what we call parallel computers. The easiest way to think about parallel computers is that they're a bunch of PCs tied together with high-speed networks, and you're able to solve very complicated mathematical equations very efficiently. And our group was one of the first in the world to switch over to this new paradigm of parallel supercomputers.
And that allowed you to simulate the atmosphere with more accuracy or simply faster, incorporating more variables?
Well, it was a mixture of the two. Our models were becoming more complicated, having more details and realistic features. At the same time, by the fact that we can sort of break the atmosphere in our model up into small areas of the globe and to calculate each of these areas and interconnect them so you had a global model was the way that this new paradigm worked.
Okay. Thank you. Now, for people who might be, young people who might be considering a career in science today, tell us a little bit about what it's like to work in one of the nation's premier science agencies and what it's like to advise policymakers, presidents in your case, on one of the most compelling issues that we've got facing us today.
Well, I actually got started in this area of science here at Oregon State. It was really a place where I first learned about atmospheric science in the late 1950s. And I got after finishing my bachelor's in physics, I switched over to a master's in meteorology and then later left Oregon State and went to Penn State for my PhD. So I take a lot of credit or I'm giving a lot of credit to Oregon State for getting me started in this new field. And since that time, I have essentially worked for 47 years at the National Center for Atmospheric Research in Boulder, Colorado. And in 1977, I was appointed by President Carter to a National Advisory Committee for the Oceans and Atmospheres, and that's where I got started my dual career of serving many presidents, all the way from President Carter to President Reagan. And then Clinton appointed me to the National Science Board, and then I became chair of the National Science Board. And then when President Bush II was elected, I was already serving on the National Science Board, and I became chair under him, under the President Bush on the second. And then Senator Obama asked me to be on a panel with him, and I've been giving advice to President Obama. On my view is that the science is basically nonpartisan. We as scientists are obligated as part of our moral duty to give advice to the presidents, irregardless of whether they're Republican or Democratic. And the important thing here is that science should not be a partisan issue. It should be an issue where we're helping not only our country out, but internationally to solve very important societal problems such as climate change.
Mm-hmm. Okay. Now, for young people thinking about going to college today, we are in a time of economic recession, when jobs aren't quite as plentiful, when we probably all know of people with college degrees who are out driving a cab or flipping burgers somewhere. And one of the concerns has been expressed to me that, well, you know, why go to college? You know, jobs are just not there. You're just wasting time. And I'm wondering how you respond to that, given your love of education, your family's encouragement to you in getting a college education. What would you say to somebody who says, you know, that's a waste of time. Why do that?
Well, I think there are several good reasons. One is that, at least in my case, I found even in high school that science was interesting, and if I can use on the word, it was fun to do. And I think that the people who are considering going to college, that you should really go for the right reason. And the right reason is you are looking for not only a reasonably good livelihood, but also in terms of what your interests are. And I think for young people who are considering different careers, science is a good one to pick. Even though the job market may not be quite what you would like, history shows that if you end up going to finish your education at the high school level versus going on to college and getting a degree, it makes a very big difference in terms of your lifestyle as well as your income if you get that college degree. And I'm trying to encourage, for example, underrepresented minorities to get into science as well as women, because it gives them a much more interesting and rich career to pursue. And there are opportunities, but I feel that I made the right choice, and I'm going to encourage students to consider science and engineering and medicine as a good area of having a very satisfying career.
Now, you came of age, so to speak, at a time when the Cold War was still going on, when Sputnik had been launched, and the nation was very concerned with catching up and getting ahead of the Soviet Union. And so there was a big push on science and engineering in the late 50s and under John Kennedy's presidency and so on, going to the moon. In your mind, thinking about the challenges in front of us today, what are the challenges that you think have come to your mind that are of a comparable nature that are as important or maybe more important than that time when we were so concerned with the space race and staying ahead of the Soviets?
Well, I think the Sputnik kind of woke up the nation that the Russians were getting ahead of us, and that sort of spurred a greater investment in science and education, science education, that has actually led to a lot of other big discoveries and benefits to society. Now, I think one of our big challenges in the future is to sort of deal with a sustainable world. And at least the field in which I'm engaged in, which is understanding climate better as well as climate change, is going to be even more important as we try to figure out how to keep the planet, the Earth's climate system and physical and chemical system, in a way that it'll serve future generations just like it's served us. So sustainability is going to be an area of great importance to the science of this country as well as international science.
And if you were advising a grandchild, a friend's child about an area of science or engineering to go into to address the questions around sustainability, what advice would you have?
Well, I still think that in order to make a contribution and to be prepared for unexpected aspects in your own career, that you need to concentrate on the fundamentals of, say, physics and chemistry and mathematics and biology. And then as you kind of get into those subjects, you figure out on what part do you want to actually make your contribution in. I mean, if you asked me at the time I was getting started, am I going to end up where I am now? The answer is probably I wouldn't have known. I had no way of knowing. But being prepared in the fundamentals really prepared me later for the things and the opportunities that came forward. So I just want to emphasize that you need to kind of be strong in some of the fundamentals in order to take advantage of opportunities.
Now, you've written in your autobiography about the importance of your family in preparing you, encouraging you to go to college, to get an education. Tell us a little bit about how they did that. How did your parents encourage you? What sorts of things did they do?
Well, I had several strong influences. On my parents, it was certainly was the most important. I was a typical high school student that happened to have an interest in science, even though many of my colleagues thought that those subjects like algebra and trigonometry and chemistry and physics were kind of nerdy subjects and a lot of hard work. I kind of ignored my peer pressure, and I decided that this was something I wanted to do. I became interested in it. My parents encouraged me, and I turned out that I made a decision to come to Oregon State. I must admit that part of my decision to come into Oregon State was I got a job as a dishwasher at the local hospital, and I worked for only $1 an hour. And of course, the tuition was very cheap here. I think it was $47 a quarter. And so I could work myself through college, basically, and sort of learn my science. And I have no regrets for anything that happened. I just want to say to the young people who might be listening to this interview that they should kind of focus on what they want to do with their lives, and not let their peers determine that. And in fact, one of the interesting aspects of my choices was that my high school counselor encouraged me not to go into science, but to go into business. I ignored that advice. I came to Oregon State as a freshman physics major, and I've never regretted on that choice. And so I think I'm an example of where sometimes the advice of others isn't always right, and you need to kind of reach down and sort of look at your own situation, your own interest, and make a decision about what you want to do.
Now, here at Oregon State, you had some adventures, as I recall reading, especially one up on Mary's Peak. Tell me a little bit about that.
Well, I had a summer job, and this was in the late 1950s, working for a professor in physics, where he was running a weather radar at the top of Mary's Peak. And they had the radar installed up there on the peak, and you could drive up there in the summertime to take the fuel up and to take the van up there and get it all set up. But then in the wintertime, you could only reach this peak by snowshoes, because there would be enough snow up there that you couldn't drive a car in the wintertime. And I recall on the weekend I was up there operating on the weather radar, monitoring storms that were coming in from the Pacific Ocean. And it was very windy, and it snowed something like 3 or 4 or 5 feet in that one night. And there was a air defense radar right next to my little van where I slept and operated on the weather radar. And it apparently got filled up with a whole bunch of snow on the antenna and fell over and just missed me by a few feet of hitting on the van. So when I got up in the morning, I looked out, and I could see this thing had crashed down, this big, huge antenna. So I called the Air Force. We had a radio telephone arrangement, and I told them that their antenna had just blown down. This was part of the air defense to spy to see whether there was incoming attack coming from some nation that wasn't friendly, I assume. And I was amazed when within a few hours I heard these noises, and 2 huge snow plows were coming up the road, blowing the snow off, and in back of the snow plows were huge cranes. And they came up and they put that antenna back up and got it operational, I think, within a day. I'm sure that somebody back in Washington, some general probably, told them to get that thing back up. And I was amazed that they were able to do all this in just 24 hours. For me, I was pleased to have survived getting crushed by this antenna falling over. But it was one of the more exciting and probably thrilling things that happened in my life when I was very young.
So science is a bit of a risky enterprise, even though we think people sitting behind computers in safe offices and so on, but sometimes you have to be out there risking your life.
That's right. In fact, in our field of atmospheric and ocean sciences, we have scientists doing all kinds of interesting things, being on ships out in storms, or flying and taking measurements in various parts of the world. So there is a kind of an interesting aspect of being an atmospheric or an ocean scientist.
Well, thank you very much. I think those are the questions I had for you. Is there anything else you'd like to share with our audience?
Well, I just want to add one thing, and obviously my wife Mary and I are very pleased to come back and to take part in the festivities of having me give lectures here at Oregon State. in the middle of next month, President Obama is going to give me the very coveted National Medal of Science Award. This is given to scientists and engineers who have spent a lifetime making contributions, and it's a very coveted award to receive from the President. In fact, I believe is the government's highest award, and I'm looking forward to that. And I'm thankful for the start that Oregon State gave me in getting started on my long career. Thank you very much.
You're welcome, and thank you, and congratulations. And I'm sure I speak for much of the community, all the community here, and tell you how proud we are of your accomplishments and how it's another example to us of the spirit of how people here make a difference in the world, and how, as a land-grant university, Oregon State is living its mission for Oregon and in the country, and indeed throughout the world, as your own work has demonstrated time and again. So thank you for being with us here today.
Thank you.